Okay, hello everyone. So today we will be looking at experiment number 12 of your experiments, which is the radiant energy of tungsten. Okay, and in this case, the tungsten material that we'll be considering is in the form of a light bulb that will be hooking up as in an electrical circuit to measure the radiant power, or the radiated power, and the absolute temperature for the tungsten surface. So the instruments or the apparatus that we need for this particular setup is first your variac. So this is our variac. The reason why it's called a variac is because it is able to produce a variable AC source. Okay, so this is a variac, and connected to a variac we have a tapping transformer. So this can be formed as a tapping transformer. However, it is simply a step down of your output from your variac, and this is giving you your output in AC as well as DC format. So this is a simple lab power supply. Okay, and in this case we will be simply using the AC terminals of the lab power supply to connect up our circuit. The other things that we need is two multimeters. So one multimeter will be used to measure the current, while the other multimeter will be used to measure the voltage of the circuit. Okay, and these are connected, given in this circuit diagram of the procedure, the first part of the procedure. Okay, so we have a variac. Connected to the variac is a tapping transformer. We have a voltmeter connected in parallel to the tapping transformer. Therefore, and the other branch is connecting your ammeter, which is connected to the bulb of your circuit. Okay, and from the bulb it is connected back to the tapping transformer. Now, before the bulb is turned on, we need to know what would be the resistance of the cold filament, which is the R0 value. Now, we have been able to determine the value of R0. Now, in this case, the value needs to be corrected from the current value of 0.57 to be a value of 0.35. So 0.35 is what you will need to take note as your second part of your results that you have. For example, the resistance of the cold filament, R0, should be reading 0.35 ohms. Okay. Another thing that we will need is the room temperature. Okay, and the room temperature right now has been determined using a thermometer, which is around 21.1 degrees Celsius. Okay, and now what we'll be doing is we will change we'll vary the voltage and the current in the circuit, and we will be able to record the power that is delivered to the light bulb. Okay, and from the power we will be able to determine the resistance of the tungsten. Is it the resistance of the tungsten, the resistivity, the temperature in Kelvin, and then finally log P and log T. So before we go further, okay, you need to also have the appendix 1, which is available. Okay, the appendix 1, which is available in your laboratory manual at the end of the laboratory manual, which is the resistivity versus temperature for a tungsten material. Okay, and the resistivity is given as the y-axis, the temperature given as the x-axis. So using this graph, you will be able to determine the value of resistivity that you need in your results. The temperature that you need in your results. So you'll be determining the resistivity. You will actually be able to determine the temperature from the graph here. So looking back at our procedure, okay, the first thing we need to do is we will need to find out the resistivity at room temperature, okay, the ρ0 value. So the rho naught value again is just determined from the appendix 1. Okay, and next is you will use the equation number 5 to determine the values of resistivity using the values of RT, R naught, and rho naught. So RT is simply the room temperature, R naught is the resistance of the cold filament, and rho naught is the resistivity of the cold filament. Okay, right. So the next part is you will need to use the values of rho and the graph of appendix 1 to determine the value of T for each set of the current and voltage readings. So current and voltage will be varied. Okay, using that you will be able to determine the power, and then from the power you will be able to determine the resistance of the tungsten material, and then from there you'll be able to determine the resistivity. From the resistivity, okay, you will need to refer to the appendix 1 in your results, in your appendix 1 to determine the value of temperature in Kelvin, and then the last two columns are simply log of the power value and the log of the temperature value in Kelvin. So once you've got your set of data ready, then you will draw a graph of log P against log T. Okay, again take note, log P is supposed to be on the y-axis and log T will be on the x-axis. So this is going to be a straight line graph in the form of y is equal to mx plus c, and it will follow the equation number 8. Okay, you have log P, which would be equal to log K plus n log T. So the value of your gradient and the value of the y-intercept will be used for further analysis. For example, if you look, this is the relationship through which we are able to obtain equation number 8. So P is equal to K T to the power n. Okay, the n needs to be determined, as well as the value of K. So to determine, so using the value of K, we can then further determine the value of sigma. Sigma is the Stefan-Boltzmann constant. Okay, and the Stefan-Boltzmann constant theoretically has been given to be close to 5.67 times 10 to the power negative 8 watts per meter squared per Kelvin to the power 4. Okay, and the experimental value will be determined using equation number 9. Okay, so using your graph that you've drawn, the y-intercept, you can do the antilog of K to find out the value of K using the value of D and L. So the value of DLL is given in procedure number 14 of your experiment. So the value of the diameter of the filament is 0.043 millimeters, and the length of the filament is 8.54 millimeters. So using this, you will be able to determine the value of sigma that you need. Okay, and this is the required values. For example, you need to determine the values of K and N. Next, we can find out the experimental value of the Stefan-Boltzmann, and then you can compare the literature, compare the experimental value with the literature value for the Stefan-Boltzmann constant. Okay, so that ends the procedure for experiment number 12. I hope you have had a clear idea of how this experiment would be conducted. Okay, we will give you the all the set of results that you need. Okay, the only set of results that you need is your voltage and current. The other is simply your analysis that you need to do on your own. Okay, so keep this appendix 1 handy with you, because this appendix 1, the graph, will be used for further analysis of your resistivity and your temperature values in Kelvin. Okay. So that ends the discussion on experiment number 12, and I wish you the very best of luck.